guys, today we're going to be solving quadratic equations by completing the square. When we solve a quadratic equation by completing the square, we have two prerequisite steps. The first one, we have to isolate the constant term, and then the second term, we have to make sure that the leading coefficient is 1. Once those two things have been met, then we can work our magic to complete the square, which is a 4-step process. So let's go ahead and do this. So our first fun problem reads, solve each equation by completing the square. So I want to point out that the directions do not give you the green light to solve this however you'd like. We have to solve it by using this technique, or that's it. So it's completing the square or bust. So let's go ahead do the two prerequisite steps. To solve a quadratic equation by completing the square, our first goal is to isolate the constant term, or in semi-English, variables on one side, numbers on the other. So cool. Let's go ahead, subtract 1 from both sides. When we do, that will leave us with x squared plus 2x. Please line up the equal sign for two reasons. One, it's aesthetically pleasing, and two, we actually need that space right there. So to complete the square, we have two prerequisite steps. 1, isolate the constant term. Done. 2, make sure that the leading coefficient is 1. Well, we don't have to do anything because it's already 1. And then 3, complete the square. So to complete the square, it's going to be a 4-step process, and I'm going to do it as a thinking area. Okay, so step 1, we are going to identify b. So bear in mind that if we had 3 terms, this will be a trinomial of the form ax squared plus bx plus c. So in this case, the value of b is 2. So to complete the square, it's a 4-step process. 1, identify b. b is 2. 2, multiply it by 1/2. Bear in mind that like a lot of the books, I think every book that I've read says divide by 2, but there's a reason to my madness. Whether you say multiply b by 1/2 or divide it by 2, it's the same thing, because dividing by 2 and multiplying by 1/2 is the same thing. But I recommend that you always say multiply by 1/2. You'll thank me later. Cool. So to complete the square, how are we gonna do it? 1, identify b. 2, multiply it by 1/2. So that will give us 1. 3, you're going to square the result. So the result is 1. And then 4, you're going to add the result. Okay. So you're going to add, in this case, the result was it's just 1. It's a coincidence that it's the same as half of b. I should have picked a better problem. But don't worry, we're going to do 3 problems to illustrate this technique. So to complete the square, 1, identify b. 2, multiply it by 1/2. 3, square the result, and then 4, add the result. So let's do this. So we're going to go ahead, add the result to the trinomial, but bear in mind, this is an equation, so if we do something to one side, we have to do it to the other. Let's go ahead, add 1 to both sides, and then now what are we going to do? We're going to factor the variable side. Okay, so we had said that we wanted to complete the square, so by some miracle, the variable side should be a perfect square. So factor however you want. So we want factors of c that add up to b, factors of 1 that add up to 2. I believe it's 1 and itself. So let's go ahead and factor x plus 1 times x plus 1. Cool. And lucky for us, the sum of 8 and 1 is 9. Fantastic. Now the question is it a coincidence that the binomials are the same? It's actually not a coincidence. We were trying to complete the square, so we wanted to have a perfect square. Let's go ahead and use exponents for repeated factors. Now I'm gonna fill you in on a little secret. Don't tell your teacher, okay? So hopefully the factoring comes to you, and if not, use the secret weapon. Whatever 1/2 times b is, that's what I want you to put it in the parentheses. So 1/2 times b is positive 1. That's how we have plus 1 plus 1. Okay, but yeah, no one's gonna know whether you genuinely factored or you use your secret weapon. Let's keep going forward. So that should equal 9. So how do we solve a quadratic equation by completing the square? 1, prep it up. So isolate the constant term. Let me cover this up. So 1, isolate the constant term. 2, make sure that the leading coefficient is 1. 3, then complete the square. When you've added that beautiful number, then you have completed the square and the rest is history. So we complete the square so we can then apply the square root property. So the square root property says to get rid of a square, let's go ahead square root. So we're going to square root both sides, and at this line we insert our plus or minus. So on the left side, the square and the square root undo each other, and that will leave us with the x minus 1 equals plus or minus whatever the square root of 9 simplifies to, which will give us 3. Fantastic. Let's isolate the x. Last time I checked, opposite of subtraction is addition, so let's go ahead add 1 to both sides. And when we do, that will give us x equals 1 plus or minus 3. So remember, your answer should not be submitted with the plus or minus symbol. We have no time for that, okay? So we have that x equals 1 plus 3 or 1 minus 3. Last time I checked, the sum of 1 and 3 is 4, and the difference of 1 and 3 is negative 2. So I want to point out the following. Our answers are rational, so if we had solved a factoring, we would have gotten 4 and negative 2. Let me say it again. Our answers are rational, meaning we could have solved by factoring if we wanted to, if we had the green light to do so. In this case, we had no choice. We had to solve by completing the square or else. Cool. So I'm not going to say that you're pros after one problem. We're going to do 2 more problems, and then that will be the end of that. Okay. So problem B. Well, I called it problem A for kicks. Okay. So we are asked to solve it by completing the square. Yeah, I had a technical difficulty, but I wanted to save a leaf. So let's do this. So how do we solve a quadratic equation by completing the square? 1, isolate the constant term. So variables on one side, constants on the other. To undo the addition, let's go ahead subtract. We will subtract 25 from both sides, and that will give us x squared minus 6x is equal to negative 25. Fantastic. So to solve a quadratic equation by completing the square, 1, isolate the constant term. Done. 2, make sure that the leading coefficient is 1. I'm going to highlight that literally. Okay, it is. 3, now we have the green light to complete the square. So I'm going to do it in a thinking area. So 1, we are going to identify the value of b. So b is the coefficient of that middle term, of the soon to be middle term, okay, or the x term. Value of b is negative 6. To complete the square, 1, identify b. 2, multiply it by 1/2. 3, we're going to square the result. And then 4, we're going to add the result. Maybe I should have started with this problem, but it's too late for that. So let's go ahead, add this perfect square number to both sides. Let's go ahead, do plus 9. Cool. That doesn't really stand out. Remind me to do it in red next time. Alright, so the left side should have a perfect square. I'm going to pretend like I'm surprised. Actually, no, we should know better than that. So the left side, let's go ahead, throw down parentheses, form the product of the first terms. To complete the binomial factors, we want factors of c that add up to b. Factors of 9 that add up to negative 6, which will give us negative 3 and negative 3. And again, if you're feeling a little bit nervous, bust out your secret weapon. Whatever half of b is, that's what you're going to put in the parentheses. So again, whether you genuinely factored or you use your secret weapon, no one's going to know. Okay. Plus, this came from you, so who cares if they know? Alright, on the right side, sum of negative 25 and 9 will give us negative 16. And again, it's no surprise that the binomial factors on the left are the same. We wanted to have a perfect square, hence the complete the square. Okay, so let's go ahead, use exponent for repeated factors so we can then apply the square root property. So to get rid of a square, let's go ahead, square root. And then at this point, we'll add our plus or minus. So on the left side, the square and the square root undo each other, and that will leave us with the former radicand of x minus 3 equals positive or negative, whatever the square root of negative 16 simplifies to. If you can do that mentally, go for it. But I'm going to bust out a thinking area because you know how I do things. I can't do things in my head. Cool. when it comes to simplifying square roots of negative numbers, the first thing we need to work on is making the radicand positive. In order to do that, we are going to replace the square root of -1 with the imaginary unit I. And then we're going to take that I and multiply it by the leftover radical, which is square root of 16. So last time I checked, the square root of 16 will give us 4. And thanks to your hard work, we will tell ourselves that the square root of -16 simplifies to 4i. So let's do this. So we have x minus 3 equals plus or minus 4i. I'm out of space. I'm going to start a new column. So we keep our cool. To isolate the x, let's go ahead and add 3 to both sides. And that will give us x equals 3 plus or minus 4i. Fantastic. So we're done. You know, we have a non-real solution. When it comes to non-real solutions, we just have to remember to put it in standard form for a non-real number, which is a plus bi. So we want real part followed by pure imaginary part. As we do, we just want to get our full credit and submit the answer without the plus or minus symbol. So first solution, or one solution, will be 3 plus 4i. And another solution will be 3 minus 4i. Fantastic. I checked it at my house. Cool. So we had said that we were going to do a total of 3 problems. This was the second one. We have one more and then we're good to go. Cool. All right. So let me go ahead and look at my notes. Problem B. So the problem reads 2x squared plus 7x. That's a 7. I should have just left it like that. 2x squared plus 7x plus 3 is equal to 0. So bear in mind that we are not given the liberty to solve this however we like. We have to solve it by completing the square. So let's prep it up, okay? So the first goal is to isolate the constant term. So we want variables on one side, constants on the other, okay? So let's go ahead and subtract 3 from both sides. That will leave us with 2x squared plus 7x is equal to -3. Fantastic. So now the next thing you want to do is make sure that the leading coefficient is 1. Unfortunately, unlike our previous 2 problems, this leading coefficient is not 1. So how are we going to handle it? Well, to get rid of the times 2, let's go ahead and divide both sides by 2. So we're going to divide both sides by 2 by dividing each term by 2. I'm always against the fraction bars. Okay, so let's do this. Quotient of 2 in itself will give us 1, so that will cancel out, and that will leave us with x squared plus whatever your heart desires. If you want to write this as 7x over 2, that's fine, but I recommend that you write it as fraction times x. That way you can easily see what the coefficient of that term is. So if we choose to go that route, that will be 7/2 x. Line up the equal side, equals -3/2. So are we good to go? To complete the square, what needs to hold true? 1, isolate the constant term. We do. 2, make sure that the leading coefficient is 1. It wasn't, but now it is. Now we have the green light to complete the square. So you know me, I love to think on the side. So to complete the square, 1, we are going to identify b. Value of b is 7/2. 2, we're going to multiply it by 1/2. So half of 7/2 equals 7/4. For problems like this is the reason why I prefer to say 1/2 times b versus b divided by 2. Because 7/2 divided by 2 still gives you 7/4, but I can do 1/2 times 7/2 in a heartbeat. Okay, I digress. So how do we complete the square? 1, we're going to identify b. 2, we're going to multiply it by 1/2. 3, we're going to square the result. So the result is 7/4. The square 7/4 and the result is 49/16. So to complete the square, 1, identify b. 2, multiply by half. 3, square the result. And then 4, add the result. Okay, so we want to add 49/16 to both sides. So let's go ahead, add 49/16 to both sides. So remember, we were not given the liberty to solve this however we like, so we have to solve it by completing the square. So on the left side, what does this factor to? Give me a sec. So on the left side, we should have product of two binomials. So to complete the binomial factors, we want factors of 49/16 that add up to 7/2. Are we expected to know that? Yeah, you're supposed to. If the numbers come to you, great, but they don't come to me, so guess what? We're gonna bust out our secret weapon. After all, it is our work, okay? So the secret weapon was whatever half of B is, that's what you're going to put in the parentheses. For this problem, half of B is 7/4, so we're positive 7/4. So let's go ahead, pencil in that positive 7/4. But don't take my word for it, although you should, because I supposedly you trust me. All right, let's go ahead and check it. Product of 7/4 and 7/4 will give us 49/16. Done. Sum of 7/4 and 7/4 is 14/4. I'm gonna say it like this: 14/4. But when we reduce it, that should give us 7/2. Done. Okay, so no one's gonna know. Keep going. Equals on the right side. Oh, to make it spicier, let's go ahead add. You could do it in your head, but I don't know how to do it in my head. Let's go ahead write those equivalent fractions. The least common denominator between 2 and 16 is 16. So when we write those equivalent fractions, that first denominator, let's give it the missing factor of 8, and then that will give us negative 24/16 plus 49/16. Fantastic. So on the left side, let's go ahead use exponents for repeated factors, so then we can apply the square root property. So that will give us sum of negative 24/16 plus 49/16. 49 minus 24 is a 5 with a 2, or 25 like how normal people speak. Fantastic. Squared part equals number part. Let's do that. Let's apply the square root property. So to undo the square, let's go ahead square root. And don't forget your plus or minus. So on the left side, the square and the square root undo each other, and that will leave us with x plus 7/4 equals plus or minus whatever the square root of 25/16 simplifies to. I know it's kind of scary with the fraction, but if you can square root 25 and you can square root 16, you're good to go. The square root of 25 is 5 and the square root of 16 is 4. So the moral of the story is that the square root of the fraction simplifies to 5/4. Let's knock it out so we can go home. So to isolate the x, to undo the addition, let's go ahead subtract 7/4 from both sides. I'm running out of space, so let me start a new column. So that will give us, where am I? So that will give us x is equal to negative 7/4 plus or minus 5/4. And then for the grand finale, let's go ahead and submit our answer without the plus or minus. So the first solution is negative 7/5 plus the fraction. And then the second solution is negative 7/5 minus the fraction. So the sum of negative 7/4 and 5/4 will be negative 2/4, and then you reduce it in a bit. Negative 7/4 minus 5/4 will give us negative 12/4, and same speech. We keep our cool. 2/4 will reduce to a half, so we're going to tell the world that one solution is negative 1/2 and the other solution is negative 3. So I understand that we didn't have the green light to solve this problem however we like, but if we did, I want to point out that our answers are rational, so we could have solved by factoring if we were allowed to. So we have a slight change of plans. Being the overachievers that we are, we're going to go ahead do C and D, and then we'll be out this time. Okay, cool. So remember, we are not given the green light to solve these quadratic equations however we like. We have to solve them by using this technique. We have to solve them by completing the square or else. Most of the time, I just say answer the question, and it doesn't say how to do it, but there will be a few times where I say you got to answer by using this technique, and if that's part of the directions, then we got to follow those directions. So I'm like, okay, how do I solve a quadratic equation by completing the square? Our first goal is to isolate that constant term, okay? So we pretty much in English, we want variables on one side, numbers on the other. So to undo that addition by 40, let's go ahead subtract it from both sides. When we do, that will leave us with x squared plus 10x is equal to negative 33. Fantastic. Our next goal, before we work our magic and try to complete the square, is we need to verify if the leading coefficient is 1. I was trying to look for my blue highlighter. So I'm going to ask myself, is the leading coefficient 1? In this case, it is. What if it wasn't? If it wasn't, then we fix it. Okay? So prerequisite steps. Okay? To solve a quadratic equation by completing the square. 1. Isolate the constant term. 2. Make sure that the leading coefficient is 1. Okay, now we're gonna go ahead complete the square, which is that 4-step process. So let me go ahead bust out a thinking area. To complete the square, 1, we're gonna identify b. So remember, this would be, if we had 3 terms, this would be a trinomial of the form ax squared plus bx plus c, and in this case the value of b is 10. Okay, b is the coefficient of the degree 1 term or of the x term. So to complete the square, 1, we're going to identify b. 2, we're going to multiply it by half. So 1/2 times 10, or half of 10, same difference, is 5. 3, we're going to square our result, which is a square of 5 is 25. And then 4, we're going to add our result. Okay, so let's go ahead complete the square by adding 25 to both sides. So we have plus 25 on the left, plus 25 on the right. Remember, that's one of our properties of equality is the addition property of equality. So like adding the same number to both sides is not going to change the solution. That's why we got to add it to the other side. Now on the left side, we should have a perfect square. If not, then we have a situation. We should have a perfect square because we're trying to solve it by completing the square. So on the left side, you factor however we like. If you want to go straight to the square of a binomial, go for it, but my mind doesn't work like that, so let me show the work. Trinomial, leading coefficient is 1, so we don't have to use the AC method to factor. So let's go ahead, throw down parentheses, focus on getting the product of the first terms. The product of the first term should give us x squared, and we will use variable times itself. To complete the binomial factors, we want factors of c that add up to b. So factors of 25 that add up to 10. If you don't need the x game, then I don't need the x game. But if you want it, then go for it. Factors of 25 that add up to 10, it's going to be 5 and itself. Okay, so we check it. Product is product is 25, sum is 10, and we're good. And if you're having a moment, don't forget the secret weapon. When you're completing the square, the numbers that you're going to use to complete the binomial factors is whatever 1/2 times b is. 1/2 times b is 5, positive 5, hence the plus 5 plus 5. Okay, on the right side, who has a calculator? Negative 33 plus 25 is 38. Sorry, that's how I count. Okay, so let's go ahead, use exponents for repeated factors so we can then use the square root property or apply the square root property. Okay, so we got a square part equals a number part. To get rid of the square, let's go ahead square root, because the square and the square root pretty much are inverse operations. So we square root the left side, we square root the right side, and please don't forget the plus or minus at this point. So when we do, after we square root both sides, the square and the square root undo each other, and that will leave us with the radicand of x plus 5 is equal to positive or negative whatever the square root of negative 8 simplifies to. With your permission, I'm going to bust out another thinking area. Yeah, because I think a lot, okay? I'm going to go ahead and bust out another thinking area so that way I can have all the space in the world to simplify my radical. When it comes to simplifying radicals, to be more specific, when it comes to simplifying square roots, our primary goal is to fix it so the radicand is positive. So we are going to replace the square root of negative 1 with the imaginary unit I, and that will leave us with I times the square root of whatever we're left with, I times the square root of 8. At this point, we are going to simplify the square root of 8 however our heart desires. If you can think of a perfect square factor, then go for it. And if you need to prime factor it, I'm all for it. Okay, a perfect square factor of 8 is 4. So we're going to write this as square root of 4 times the square root of 2. We square root what we can, namely the 4. Square root of 4 will give us 2. and that is being multiplied by the square root of 2. Let's write this so it's a little bit easier on the I, and that will leave us with I times 2, or 2 times I times the square root of 2. So let's go ahead and bring that to the table. Okay, so we have x plus 5 equals positive or negative, whatever the square root of negative 8 simplifies to, which is 2i root 2. Okay, let's take our time. So to finish it off, let's go ahead, isolate the variable term, namely x. To undo the addition by 5, let's go ahead, subtract 5 from both sides. And that will leave us with, where am I? X equals whatever you want. Well, not really. X equals negative 5 plus or minus 2i root 2. Now, someone asked me, is it okay if we put the 2i root 2 first and then the minus 5? Well, technically I'm supposed to say yes, but because we have a non-real complex answer, we have to make sure that our answer is in standard form for a complex number, a plus bi. So it's vital that we put the real part, then the pure imaginary part at the end, or in English, we put the I at the end. So the real part is negative 5. And then we're going to add or subtract the pure imaginary part, which is 2i root 2. So that is our answer. We cannot simplify it further. We have it in standard form for a complex number. Let's just go ahead and write our answers without the plus or minus sign. So one solution, negative 5 plus that bad boy. The second solution, negative 5 minus 2i root 2. Let's go ahead and split it. So we have negative 5 plus 2i root 2, and the other answer is negative 5 minus 2i root 2. Fantastic. Okay, so let me go ahead, write problem D, and then we'll do this fairly quickly. Remember to pause and rewind as many times as needed. Okay, so for the grand finale, we have negative 3x squared minus 6x minus 7 is equal to negative 9. Remember, we are not given the green light to solve this quadratic equation however we like. We have to complete the square. Prerequisite step when it comes to solving by completing the square is to isolate the constant term and then take it from there. So in English, we want variables on one side, numbers on the other. So inverse operation of subtraction is addition, or like undoing. So to undo a subtraction, we have to add it to both sides, and that will leave us with negative 3x squared minus 6x equals negative 2. I know you're super pumped and you're like, boom, let's go ahead, complete the square. But remember that second prerequisite step, what I call them prerequisite step. In order for you to complete the square, one, you have to isolate the constant term. So like numbers, variables on one side, numbers on the other. And then two, you got to make sure that the leading coefficient is 1. If you don't fix it so it's 1, this is going to be unnecessarily tougher than it has to be. Okay, so I'm like, man, how am I going to make this coefficient to look like 1? Well, that's easy. Ask yourself, what are you going to do to get rid of the times negative 3? Okay, to get rid of the times negative 3, let's go ahead, divide both sides by negative 3. I'm really against the long fraction bar because I tend to do silly mistakes, and I love myself, so I'm going to divide each term by negative 3. Once we divide both sides by negative 3 using the notation of our choice, that should lead us to x squared plus 2x is equal to positive 2/3. Fantastic. So then I'm like, okay, am I good to go to complete the square? Prerequisite step number 1, did we isolate the constant term? Yeah, cool. Prerequisite number 2, is the leading coefficient 1? Yes, it sure is. So now that we have this bad boy how we want it to look like, let's go ahead, complete the square. So remember, to complete the square, it's that 4-step process. Step 1, identify b. So remember, when we have these 3 terms, this will be a trinomial of the form ax squared plus bx plus c. So in this case, the value of b is 2. So step 1, identify b. Step 2, multiply b by 1/2. So 1/2 times 2 is 1. Step 3, you're going to square your result. So the square of 1 is 1, and then step 4, you're going to add your result. So again, it's just a coincidence that half of b and the square of our result is 1, but that's not always the case. Let's go ahead, add 1. When we add 1 to both sides, you factor however we like. You can go straight to the square of your binomial, but I can't think that far ahead, so I'm just going to factor however I can. Remember, memorize what you have to, but digest as much as you can, and you'll go a really long way. Okay, so trinomial leading coefficient is 1. Let's go ahead, throw down parentheses. Focus on getting the product of the first terms. Product of the first term should give us x squared. We will use variable times itself. To complete the binomial factors, we want factors of c that add up to b, factors of 1 that add up to 2, and in this case it's going to be 1 and itself. And again, if you're having a moment, bust out the secret weapon. Whatever half of b is, that's what you're going to use to fill in the parentheses. So in this case, we're supposed to use that plus 1. Do it however you want. On the right side, 2/3 plus 1. Under normal circumstances, I would be like, I gotta bust out the LCD. But the sum of 1 and 2/3 is just the sum of, it's just a 1 and 2/3. Okay, but if you want to do LCD, go for it. On the left side, let's go ahead, use exponents for repeated factors. So that will give us square of x plus 1 is equal to 1 and 2/3. Yeah, I'll leave it like that. So fantastic. So now that we have completed the square, let's go ahead, apply the square root property to finish solving it. So to undo the square, let's go ahead, square root. And then at this point, we'll insert our plus or minus. And that will leave us with the following. The square and the square root undo each other, so that will leave us with the radicand of x plus 1 is equal to plus or minus the square root of whatever your heart desires. I'm not a big fan of taking square roots of mixed numbers, so with your permission, right now we're going to write 1 and 2/3 as an improper fraction. So 1 and 2/3 is the same as something over 3. 1 times 3 is 3, plus 2 more is 5. Cool. That's still not so pretty, but at least it's a little bit prettier. All right. So before I try to isolate the x, it's easier for me if I simplify the radical first. So let's go ahead, simplify the square root of 5/3 on the side. When you're square rooting, let's go ahead, rewind. The question is, how can I tell if my radical is simplified? Pretty much, if you are square rooting a fraction, we have a hidden radical in the bottom. So let's go ahead, use the quotient rule to split the top from the bottom. So we're going to write this as square root of 5 over square root of 3. Now that we use the quotient rule for radicals to rewrite it, it's a little bit easier to see why the radical is not simplified. If you had a fraction, we don't want a radical in the bottom. So the question is, what are we going to do to rationalize the denominator? I mean, you digest it however you can. This is how I'm going to do it. We're going to go ahead, highlight the index. In this case, the index is 2. So pretty much I'm going to ask myself, how many factors of that base do we have? We currently have 1. How many more do I need to get to 2? Well, last time I checked, 1 plus 1 is 2. So we need one more factor of 3. So to rationalize the denominator, we're going to multiply the top and bottom by one more factor of 3. Okay. Square root of 3 times the square root of 3 simplifies to whatever your heart desires. You can go straight to the simplified answer, or we can just multiply the radicands. I'm going to take that route. Product of 3 and itself will give us 9. So that will give us square root of 9. For the numerator, square root of 5 times the square root of 3 will give us square root of 15. We simplify whatever we can. Square root of 9 is 3. And the square root of 15 just stays as such. 15 doesn't contain a perfect square factor, so we're good. Okay, so thanks to our hard work, we have that the square root of 5/3 simplifies to the square root of 15 over 3. So let's bring that to the table. So we have x plus 1 is equal to plus or minus square root of 5/3, which simplified to square root of 15 over 3. Okay, fantastic. So To finish it off, let's work our magic to isolate that variable. To undo the addition by 1, let's go ahead subtract 1 from both sides. And that will leave us with x equals -1 plus or minus square root of 15 over 3. Let's go ahead, take our time, and then add or subtract them, okay? So we only have, so we got a fraction, there's only one denominator, so whatever that one denominator is, that's the LCD. Okay, let's write those equivalent fractions. So I'm going to write -1 as an equivalent fraction with denominator 3. Right now there's no denominator. Let's go ahead, tag one up. Okay, we're going to write -1 as integer over 1. To make that 1 look like the common denominator of 3, let's multiply top and bottom by 3. And that will leave us with x equals -1 times 3 is -3. Over 1 times 3 is 3. Bring down the rest of the problem. Oh, I'm crying because we're almost done. Okay, so now that the denominators are the same, we can proceed to add or subtract. Okay, so we have x equals -3, the operation, plus or minus square root of 15. So we're going to add or subtract and then write that over the common denominator of 3. Okay. Now the question that I'm going to ask myself is this: is the answer reduced? And I'm like, I don't know. Does 3 square root of 15 and 3 have a common factor other than 1? And the answer is no. Okay, the popular mistake is that students will want to cross cancel the 3 with the 15, but no, like it's if you're gonna divide, it's pretty much, I'll say it like this: cancel like outside factors with other outside factors, and like inside factors with other inside factors. Okay, but I spoke too much. Let's go ahead, earn our full credit. Let's submit our answer without the plus or minus symbol. So one solution is given by -3 plus the radical divided by 3, -3 plus the square root of 15 over 3. And the other solution is given by -3 minus the square root of 15, and then we divide it by 3. Okay guys, that's my time, and this time I mean it. Thanks.